Hello, welcome to today's lesson. This is our fifth lesson for the semester in our second year of our 4-year BA curriculum. I hope you enjoy the lesson. I'll see you after the lesson. This will be our lesson outline for today. We look at a brief description of the lesson, the main purpose as to why we are undertaking this lesson. We look at some learning outcomes, its indicators, and then go into our main concept for today, and that will be teaching nature of solutions. Once we get to the subject matter, we are going to look at what solutions are, clear some misconceptions that has to do with solutions, look at some types, and then how we can then calculate the concentration of various solutions. In the calculation of these concentrations, we would express them in so many ways. Look at least 3 of them. In the latter part of the lesson, we then discuss how we can teach this topic or concept to our junior brothers and sisters at the junior high school level and the primary school level. We look at how we can assess ourselves after the lesson, whether we have achieved our learning outcome. I've provided you with some references in the latter part of this video. This lesson will deal with the nature of solutions. Look at some types of solutions, the 3 types of solutions that we will deal with would be unsaturated, saturated, and supersaturated solutions. We then look at how we can measure the different concentrations of solutions. By measuring, we look at percentage by weight, mole fraction, molarity, parts per million, and parts per billion. It's expected that this lesson will help you as student teachers to be able to recognize the composition of some solutions and also give some common ways as to how we can express these concentrations. In order to help you as student teachers, we'll do a little demonstration as to how we can teach this concept to our junior high school learners. Now, the purpose of the lesson. As teacher scientists, it's expected that you have these skills and knowledge in order to teach this subject matter about solutions. Without this skill and knowledge, you wouldn't be able to clear misconceptions of your students. All these are in line with the national teaching standards. And here the references would be 2C, 3E, and 3L. After this lesson, we are expecting that as student teachers, you should be able to describe the characteristics of solutions and how to measure their concentrations. Teaching nature of solutions. What do we mean by solutions? What are your definitions of solutions that you already know? If there is a mixture of 2 or more substances, how do you know or how do you define them as solutions? We are looking at solutions as a homogeneous mixture of a solute or solute that should be able to dissolve in any solvent. Here, when we talk about a solute, we mean that any substance or material that is present in a lesser amount. Lesser amount here means that the amount as compared to the one in the mixture is smaller, or there are substances that are in smaller amount that is being dissolved. I hope you get the definition. Solvents, in the other hand, are substances or substance that's present in greater amount. And here, we can also say that the solvents are the substances doing the dissolving. That is, they are the dissolving medium. By looking at a solution, it's expected that it will be practically impossible to distinguish the solute from the solvent. However, it must be stated that a solution can exist as a solid, liquid, or a gas. Now, all these are dependent on the nature or the state of the solvent, which we have already said are in greater amount. So then again, we are saying that a solution is made up of a solute and a solvent. The solute being the smaller amount, the solvent being the greater amount. The solute is the one being dissolved, whilst the solvent is the dissolving medium. I hope the concept is clearer now. Very good. Now let's move on. Having looked at the constituents of solutions, let's look at the types of solutions we can talk about. Here we are saying that you can abbreviate the types in order to help you remember them. S, U, and S. The first S meaning saturated solutions. Say the word again, saturated solutions. The U here stands for unsaturated solutions. Unsaturated solutions. Then the last type being supersaturated solutions. Supersaturated solutions. What are saturated solutions? By definition, we are saying that any solution can be said to be saturated when that particular solution contains maximum amount of solute in a given solvent at any specific temperature. This kind of solution still has undissolved solute in it. Remember, these undissolved solutes should have been at when the solution is in equilibrium. So, by this definition, we are saying that a saturated solution should contain some undissolved solute. Unsaturated solution. Remember that when defining saturated, we made mention that the solutes are in maximum amount. For unsaturated solution, the solute here are in lesser amount. And the solute here can be dissolved in the solvent. The solution, however, is not in equilibrium, but the solutes here are all dissolved. Not in equilibrium, the solutes are also all dissolved, meaning that the solvent can easily dissolve any amount of solute that will be added to the solution. Can we now spot the difference between saturated and unsaturated solution? Just by looking at the definitions for the two. One has maximum amount of solute, the other has less solute. One solution is in equilibrium, the other is not. One solution has undissolved solutes, whilst the other has all the solutes being dissolved. Now, the solution with the solutes all dissolved has the capacity to dissolve more solutes. I hope you have written something down in order to help you differentiate between saturated solution and unsaturated solution. Now let's look at the last S, supersaturated solution. In this type of solution, we are saying that the solution has more solutes than normal, and it is quite unstable. It is quite unstable. Please note that it's very, very important. The solution is unstable. Hence, it needs no disturbance. However, once the solution is disturbed, the excess solute in the solution tends to form crystals. Note, this solution needs no disturbance. But once it's been disturbed, the excess solute in the solution would form crystals. These are the three types of solutions we have. Now let's look at how we can calculate the concentration of a solution. Before that, when we say a solution is concentrated or the concentration of a solution, what do we mean? We are saying that concentration of a solution, it's when any amount of solute is present in a given amount of solvent, or any amount of solute that is present in any given amount of solution. It doesn't matter however expressed the terms it's in. What are some of the characteristics of solutions that we can talk about? We are saying that when you look at a solution, the particle distribution should be uniform. By uniform, we mean evenly distributed. Now, when you leave the solution to stand for a certain number of time, you realize that you don't have any clear separation in terms of the solute and the solvent. That should tell you that indeed that entity or material, it's a solution. We can also say that solutions cannot be separated by filtration. A solution, from the definition, can be said to be composed of different constituents. Now, it can again be said that liquid solutions in general has to be transparent. Solutions can be separated by physical means. You can research on more characteristics of solution. Having explained what concentration of a solution is, how then, as student teachers, can we express the concentration of any given solution? Now, the first expression of concentration of solution that we are going to look at, it's expressing concentration by percentage weight. That is percentage weight per volume or weight to weight percent. We can again look at volume to volume percent. Let's pick our notepads, our pens, and let's do some small calculation from this time forward. The first one we are going to look at is expressing concentration at units of solute. At units of solute. The first expression is weight to volume percent. Just like the name or the phrase sound, weight to volume. It means weight over volume. Weight to volume means weight over volume. Now, once we add the percent to it, weight to volume percent, what it means is that the weight of the solute over the volume of the solution multiplied by 100. Again, weight to volume percent means the weight as expressed in grams over volume of solution as expressed in milliliters, all multiplied by 100. So you have the expression mass over mass of solute into bracket G over volume of solution into bracket milliliter multiplied by 100. Remember, the units are very, very important. The answer you get should be expressed in percentage terms, accompanied by your W over V. Again, the answer you get should be accompanied by percentage W over V. Such is how you express weight to volume percent. We will be looking at some examples very soon. Now let's look at the weight to weight percent. Just like the concept of weight to volume percent, this can be expressed as weight over weight multiplied by 100. That is mass of the solute over mass of the solution all multiplied by 100. In this instance too, we are saying your answer should be accompanied by percentage W over W. Isn't it easy? Very good. Don't let the formula or the expression confuse you. Volume to volume percent. Just like the previous percentages that we have already talked about. V on V, volume of solutes over volume of solution. That expression multiplied by 100. Remember, they are all in milliliters because here we are talking about volume. I've given an example here. Let's try and solve them together. Now let's look at this example in terms of how to express concentration of any solution. This time around we are dealing with weight to volume percent. So now let's read the question together. What is the weight to volume percent concentration of 250 ml of aqueous sodium chloride solution containing 5 grams of sodium chloride? Just like we have done in the previous examples, let's all identify the variables from the question. From here, we are saying that we are supposed to find the weight to volume percent. Then we also have been given the volume and then the mass. So let's write our variables. Weight to volume percent is unknown. However, the volume has been given to us as 250 ml. Our weight is 5 grams. From the formula expressing the weight to volume percentage, you realize that the numerator becomes our mass or the weight, whilst the denominator has our volume. All this is multiplied by 100. So we are looking at 5 grams over 250. 5 grams over 250 ml. Let's use our calculators to calculate for the answer. Multiplied by 100. So the answer we got from 5g over 250 ml, all multiplied by 100. What answer are you getting? Very good. The answer I'm getting is 0.02 from this alone, multiplied by our 100. and that is given at 2% weight per volume. 2% weight per volume. Now let's go over the example we have done just now. First of all, we are saying that once you have your question, what you need to do is to point out the variables in the question. And here the variables that we pointed out were the weight to volume percent, which is being demanded by the question, the volume of the aqueous sodium chloride, which is 250 ml. The last variable that we can locate in the question is that of the weight, which is 5 grams of the sodium chloride. Having seen these variables, we would put the variables down before we solve our question. The variables here, the first one being the percentage weight to volume, which is unknown, which we are supposed to calculate. The volume given in the question as 250 ml, weight at 5 grams. From the formula of the weight to volume percent, you realize that the weight is supposed to be the numerator, while the volume it's the denominator. The formula isn't complete without multiplying that expression by 100. So slotting in our variables, we have 5 grams divided by 250 ml. You can first divide this before you multiply by 100, or you multiply the numerator by the 100, then you divide all by 250 ml. So going by the first step, let's divide 5 grams by 250 ml, giving us 0.02. This answer is then multiplied by 100, which then gives us 2% weight to volume. This then becomes our concentration for the sodium chloride solution. I hope you got the answer correct. Try your hands on more examples in order to be familiar with such expressions. Now let's move forward with our lesson. Having solved the previous examples, let's look at a little more complex example. It's quite easy. Try and solve it on our own before we can work it together. Let's give ourselves some 2 minutes to solve this example. Let's look at this example. 10 grams of barium chloride is dissolved in 90 grams of water. The density of the solution is 1.09 gram per milliliter. Calculate the weight to volume percent concentration of the solution. I'm going to read the question again. Let all follow the variables in order not to confuse ourselves. 10.00 gram barium chloride is dissolved in 90.00 gram of water. The density of the solution is 1.09 gram per ml. Calculate the weight to volume percentage concentration of the solution. So you realize that from the expression of the weight to volume percentage formula, it's supposed to be the weight of the solute over the volume
of the solution. Here, the volume has not been given to us directly. So what do we need to do in order to get the volume of the solution? Taking into consideration that the density of the solution has been given to us. Very good. It means that we have to calculate the volume from the density that has been given to us. I've given hints as to how we can solve this question by identifying our solute and dissolvent. Now let's solve it together. So the first step is to find the total mass of the solution, which is BaCl2 equals 10.00 grams. That's of water equals 90.00 grams. What is our total weight? So T equals 10.00 plus 90.00 all grams, giving us 100.00 grams. That is the weight of the solution in terms of gram. From the question, we have our density. So density equals mass over volume. We know our density to be 1.09 gram per ml. We now know our mass to be 100 grams. Now let's look at finding the volume. By change of subject, we have V equals mass over density, which equals 100 over 1.09 gram per milliliter. Volume equals, let's cancel out the grams, 100 divided by 1.09. What answer are you getting per your calculation? The answer I'm getting is 1.74 milliliter. Did you get the same answer? If not, please go back and look at your change of subjects and the variables. Now to the second part of the question. Once we have the volume now, per the expression weight per volume, the total weight for the solute then becomes 10.00 gram over the total volume for the solution, which is 91.74 ml. This equation is not complete without multiplying by 100. What answer are we getting? So we can just do the numerators before. So we have 1 0 0 0. Are we done? Is the numerator correct? Very good. All over 9 1.74. The final answer then becomes 1000 divided by 91.74, which is giving us 10.90 percentage weight per volume. Did you get the same answer? If not, let's revisit the first part of our solution. The key part here is that we are to identify the variables in the question. We identified barium chloride to be 10.00 grams, water to be 90.00 grams. We have to calculate for the total weight in order to get the total weight of the solution. This was done by adding the mass of barium chloride in water. Once that was done, given the density of the solution, we can then calculate for the volume. The volume was calculated by using the formula density equals mass over volume. The mass was 100 gram, volume was 1.09 gram per ml. Making V the subject, we had M over rho, which was 100 over 1.09. That gave us an answer of 91.74 ml. The second part of the question was to calculate the percentage weight to volume, which was 10.00 gram for barium chloride all over the volume of the solution, which was 91.74 ml. Don't forget to multiply by 100, which gave us 1000 over 91.74, giving us an answer of 10.90 percentage weight per volume. I hope the answer is same as yours. I have provided you with similar questions to help you get used to these kinds of questions. Take a few minutes to solve them and let's continue with the lesson.
Now, another way that we can also express concentration of any solution is using the mole fraction. From our previous lessons, we know what mole is. In the mole fraction, we are saying that it can be defined as a unit of the amount of a constituent, which is being divided by the total amount in terms of moles of all constituents in a mixture. That is, when you pick one mole, or when you pick the mole of one constituent, you would have to divide it by the total number of moles contained in the solution that you have. Here, we are expressing it as XA or X equals moles of the constituent divided by total moles of the solution. So far, we have looked at expressing concentration of any solutions using the weight to weight percent, weight to volume percent, volume to volume percent. We've also looked at expressing it in terms of mole fraction. Now let's look at expressing concentration in terms of molarity. Say again, molarity. In this instance, we are expressing the number of moles of the solute per a liter of the solution. That is, the amount of solute in terms of the moles contained in a liter of the solution. It's stated that it is easier to measure volume of solution than to weigh the solution. How do we express molarity formula-wise? Here we are saying moles of the solute over liters of solution. Here the liters is just the volume. So you have our formula as N in terms of mole over volume expressed as dm cube or liter.
Okay. Now let's look at this example. The question reads, what is the molarity of 600 ml of potassium iodide solution that contains 5.50 moles of the solute? So this is a question that is expecting us to calculate for the concentration of potassium iodide solution. So here the key variables that we need to identify from the question are molarity. Then we are looking at the volume. And then the third variable is the number of moles. Now let's solve this together. I would advise that you begin by writing the variables from the question. The variables then becomes, we know concentration to be unknown. The volume has been given in the question at 600 ml. The number of moles also given as 5.50 moles. So what formula can we use to answer this kind of question? Looking at the variables, the formula that comes to mind is N equals concentration times volume. That is, the number of moles equals the concentration of the solution multiplied by the volume. Now let's put our variables inside the equation. We know N to be 5.50 moles equals concentration, which is unknown, multiplied by the volume. We are supposed to find C. So what do we do in order to make C stand alone? We have to divide both sides of the equation by the volume, which is 600 ml. So we are dividing both sides by the volume. So by convention, 600 goes into itself 1, then it cancels out the denominator. So the then equation becomes C equals 5.50 all over 600. From the calculation, you realize that your answer is going to be 0.0092 approximately. Because the question is seeking for the molarity, you can add the unit at capital M or express your answer at C equals 0.0092 mole per milliliter. This then becomes the molarity of the solution. Now let's go over the key aspects of solving this equation. We are saying that the first thing that you have to do in order to solve the question is to identify the variables in the question. Once the variables have been identified, you write them down. This will give you a hint as to the kind of equation you need to solve this problem. So we wrote our variables as C, V, and N, representing concentration, volume, and the number of moles. From the variables written down, we were able to write our equation. From the equation, we realized that we need to make C the subject. Once we slot in the figures, we then make C the subject by dividing across both sides of the equation by the volume, which gives us C equals 5.50 moles over 600 ml, giving us an answer of 0.0092 molar or 0.0092 mole per ml. I hope you followed the process at arriving the answer. Let's look at more examples in the other context of solving the concentrations of solutions.
Parts per million, it's one way of also expressing concentration. It's defined as the microgram of solute per gram of solution. For aqueous solutions, the units are often expressed as milligrams. So, milligrams of solute over grams of solution multiplied by 1 times 10 to the power 6. 1 times 10 to the power 6. So the whole formula then becomes milligrams of solute over grams of solution multiplied by 1 times 10 to the power 6, or 1,000,000, 6 zeros after the 1. I hope you get the expression. Let us solve an example in order to get a clearer picture of how concentration is expressed in ppm. Having looked at the concepts in terms of content of what solutions are, how to calculate their concentrations, the types of solutions, and their characteristics. How then do we transform these concepts that we know to students in the junior high school or primary level? Here, we are advising that before you begin your lesson, ask the students about how they understand the term solution. This will help you clear misconceptions of your learners before you start explaining these concepts to them. You can introduce some samples of solutions, one that will involve solid-solid and the other solid-liquid mixture. Most of our students in the JSS and the primary level only think of solutions as when they involved liquids. Use that to explain solutions in order to clear their misconceptions. Having done that, introduce solutes and solvents to them. Give them some time to see if they can explain to you what solute and solvent mean. You can then develop your own definition from the ideas of the learners. They will help them feel part of the lesson. You can group them, or you can just do a pyramid discussion. Having defined the solution and their types, you can then initiate a discussion on what we mean by concentration. So just pick water as a way of example. Add a salt to it for your demonstration. So fill half glass with water. So two separate glasses with the same volume of water. Now, just take 1 teaspoon of salt and place it in one of the glass. Whilst on the other glass, you can put in 3 or 4 teaspoons of the salt. Allow the students to come and then taste these solutions by dipping their finger in both solutions. Ask them the difference in terms of the taste. Use that idea that the students will bring up to explain concentration to them. You have to, first of all, tell them which of the two is the solute and the solvent. Use that to explain the terms amount of substance, mass, volume, and then give them some time to relax. Then you can introduce your calculations based on the variables that you've been listing on the board. Very good. We can then move on other ways that we can teach solution to our learners in GHS and primary. Having introduced your lesson, delve into the concepts, and started your calculations, I would advise that you start with low order questions before you introduce the complex questions to them. Let your learners be mindful of change of subject in terms of the formulates used to express the concentration, especially when you don't give straightforward questions. You can lead by solving two or more questions with them. Then you give them examples to solve on their own. This will help them appreciate how they have understood the concepts. It will help your class to be more lively as well. As you solve the questions, once a student answers the question correctly, you can give your marker or the chalk to your student to come and solve on the board and then explain to the whole class how the answer was arrived at. I'm sure you'd have many of your students being able to solve such questions after this exercise. We looked at what solutions are. What constitutes solutions? What is concentration of a solution? How can concentration of solutions be expressed? Characteristics of solutions was also looked at. Plus, we also talked about the types of solution. We worked some examples and also advised ourselves as to how we can teach these concepts to learners in our junior high school and primary. I hope you have enjoyed today's lesson. I'll come again next week as we looked at another concept in science. It's going to be very, very exciting. I hope I see you in the classroom. Thank you, and also don't forget to wear your nose mask in this COVID era. It's very, very important. Wash your hands and the running water with soap. Don't forget your hand sanitizer too. And let's all keep social distancing. See you and have a nice week.
Many dance